Welcome back to my channel, and in this video we are going to learn about insertion in AVL tree. There are basically three rules to follow. The first one says insertion takes place according to the rules of BST. What are the rules of BST? The first element, it has to be the root. Okay, and from the second element, if the element is less than the root, then it would be on the left hand side. If the element is greater than the root, then it would be on the right hand side. Now, after inserting each element, we need to check the balance factor of each node. Balance factor lies in the range of +1, 0 and -1. Let's see how we insert BST. This is a basic example. Suppose I'm taking 50. Left of 50 is 40. Now, if the next element I want to insert is 60, then it would be at the right hand side of 50. So, this is basic rules of BST. Now, to check the balance factor, all the leaf nodes would have 0 and 0. Coming to the 50, height of left balance factor is nothing but height of left subtree minus height of right subtree. Okay, so height of left subtree is 1, like the number of levels it has on the left hand side, and coming to right subtree, it is also 1 number of levels on the right hand side. There is only one level, so that's the reason 1 minus 1, that is equal to 0. Now, if the tree is not balanced, I mean if it is not in the range of balance factor, then we use the following AVL rotations to make it balanced tree. Now next comes AVL rotations. AVL rotations. If we are having LL rotation, then we use the right rotation. If it is a RR rotation, then we use left rotation to solve it. If it is LR rotation, then we directly can't solve it. So we first convert it into LL, and then we know how to solve LL. We need to do right rotation. Now where do we do this LL? We do it at the parent. Okay, suppose there is an element like 50, and left of 50 is 40, and next we are having 45. Now this is LR. So first we do left rotation at parent, and then we'll get something like 50, 45 and 40. Now we'll do the right rotation because now it is in the form of LL. That's it. Now coming to RL, the same rule. The first letter is R, so we convert it into RR. RR is nothing but we rotate the parent part to the right hand side, this side. And then again we'll do the left rotation at the node where we are having the problem. Now, using all the three rules and the AVL rotation rules, we have to construct an AVL tree with the following elements. So let's start it. I have already made a video on AVL rotations. Go check out that. Then you'll have a good clarity to solve this problem. The first element is taken as the root node. So it is 26. Now the next element is 31. It would be right of 26. Now if you check the balance factor, it is said to be balanced because leaf is 0, and coming to 26 it is -1. Now next is 35. It is also greater than 26 and greater than 31. So now if you check the balance factor, let me change the color to show the difference. Leaf node would have 0, 31 would have -1 because it is 0 minus 1, 26 would have 0 minus 2. So now the problem has occurred due to insertion of 35. So it is because of RR. How do you solve RR? We simply do left rotation at the node where we got the problem. So 26 is simply rotated to the left. Now let's redraw the diagram. 31 would now become the root node, 26 at its left, and then 35 at its right. The next element to insert is 14. Where do we insert 14? Left of 31 and left of 26. Now checking the balance factor, leaf nodes will have 0, 26 is 1, 31 is having 2 minus 1, that is 1. Now inserting 9. Left of 31, left of 26 and left of 14, that is 9 over here. Now again we need to check the balance factor. So 1 second. 9 will have 0, 14 will have 1 and then 26 will have 2 and 31 would have 3 minus 1, that is also 2. Now why has this problem occurred? Because of insertion of element 9. Where is it? Left, left. So it has occurred due to LL problem. So to solve this, we actually check the balance factor from the leaf node. So that's the reason we need to first solve the problem which has occurred first. So first we'll solve this problem. So LL problem is solved by simply doing right rotation at the node where we are having problem. So 26 is simply rotated right side. Now let's redraw it. 31 would be as it is. Right of 31 is 35 and then left side it is 14 above and right side of 14 it is 26, left of 14 it is 9. Okay, now if you check the balance factor, all the leaf nodes will have 0, 14 will also have 0 because it is 1 minus 1. Coming to 31, it is 2 minus 1 because there are two levels. So 2 minus 1, that is equal to 1. Now all are said to be balanced. Now let's insert 19. 19 is left of 31, right of 14 but left of 26. So now if you check the balance factor, all the leaf nodes would be assigned 0. 26 is 1. 14 is 1 minus 2, that is minus 1. Coming to 31, it is 3 minus 1, that is equal to 2. Why has this occurred? Due to the insertion of 19. So where is it? Left, right. Now how do you solve LR problem? We first convert it into LL. To convert it into LL, the parent part, this is the parent, this is the child and this is the grandparent. So the parent part is rotated towards its left side. So again drawing it, we'll have 31, 35 as it is in the right hand side. Now 14 is rotated to the left, so 26 would take its place. Left of 26 we need to draw 14. Left of 14 there is 9 and right of 26 there is nothing. But the 19 element would go and attach to 14 at its right side because it also follows BST rules. Now this is in the form of LL. Now what do we do next? We need to do right rotation to solve it. Where? At the node where we are having problem. So this is the node 31 is the node where we got the problem. So we'll simply do the right rotation at node. So now 26 would become the root node. Left of 26 is 14 and the left part would be as it is. And 31 would be right of 26 and right of 31 there is 35. Now this tree is said to be balanced. Now next we need to insert 33. So let's insert 33. That would be right of 26, right of 31 but left of 35. Okay. Now if you check the balance factor, all the leaf nodes will have 0 and 0. 35 will have 1, 31 will have minus 2, 14 will have 0, 26 will have 2 minus 3, that is equal to minus 1. Now 31 is the problem. Why has it occurred? Due to insertion of 33. It is at right, left. So RL problem. To solve RL, what do we need to do? We need to convert it into RR. At parent, we need to do simply right rotation. This is the child, this is the parent, this is the grandparent. So at parent we need to do right rotation to convert it into the form of RR. So let's write. The left part would be same as it is and but the right side part 35, it would go to the right side, so 33 will take its place. Now, since this is in the form of RR, we need to do left rotation, where at the node where we are having problem, 31 is the problem, so we'll simply rotate it to the left hand side. So 26, next is 14, left of 14 is 9, right side it is 19, and then we are having 33 over here, left of 33 is 31, and then 35. Now this tree is said to be balanced. Now next we need to insert 23. 23 is left of 26, right of 14, and also right of 19. So now if you check the balance factor, all the leaf nodes will have 0 and 0. 19 would have -1, 33 would have 0, and 14 will have 1 minus 2, that is -1. 26 will have 3 minus 2, that is 1. The next element to insert is 20. Coming to 20, it is left of 26, right of 14, right of 19, but left of 23. Now if you check the balance factor of the following tree, all the leaf nodes you should first assign them as 0. Then 23 is having 1 because only left subtree it is having, and 19 is having -1 again. No, -2. And coming to 14, it is having 1 minus 3, that is -2. Then 31 is again having 0, and 26 is having 1, 2, 3, 4, 4 minus 2, that is equal to 2. See, at a time 3 problems have occurred. So first since we are checking the balance factor from top to bottom, so first whichever problem comes we need to solve it. So we'll solve the problem number 19. So it has occurred due to RL. How do we solve RL? We need to first convert it into RR. RR is nothing but right rotation at parent. This is child, this is parent, and this is grandparent. So right rotation of 23. So let's redraw it. 26 would be as it is. Right part of 26 is also as it is. Now the left part is 14, 9. Right side part will rotate 23 to the right. So 20 would take its place and 23 would be right side of 20. Now after this, since it is in the form of RR, see this is our problem. So we'll make a left rotation at the node where we are having problem. So 19 is our problem, so we'll simply rotate 19. So let's draw this. 26, right side part is the same. Left side we are having 14, left of 14 is 9. Now here comes the major part. 20 would replace 19 and 19 would get bent to the left, and then 23 over here. So now if you check the balance factor, all the leaf nodes will get 0, 0, 0, and 20 would get 0, 33 also would get 0 because it is balanced. 14 would get 1 minus 2, that is equal to -1. 26 will get 3 minus 2, that is equal to 1. So all the nodes are said to be balanced, and we have completed the following AVL tree. So this is the final AVL tree. Hope this concept is clear with you, and don't forget to like, share, and comment your opinions below, and don't forget to subscribe to my channel if you are new. And thanks for watching. See you in the next video. Bye bye.